Welcome. We're now doing Module 5 Homework 4. This is another method of factoring. This is called factoring using special products. What do I mean by special products? I mean these formulas right here, which you do need to know. We'll take a look at these formulas. We'll come back and take a look at these formulas as we need them. So let's look at the beginning here. We're going to look at formulas 1 and 2. We're going to do the following. We're going to take the middle term of formula 2. We're going to divide that by 2, and then we're going to square what we get. And after that, we're going to multiply the two outer terms together. So let's do that. We'll take the middle term. We'll divide that by 2. And then we'll take that answer and we'll square that. Now, the other thing it said to do was take the two outer terms and multiply them together. Notice we get the same thing. So when you do that, if you try that on formula 2, you'll see you get the same thing. Not the other formulas, but formulas 1 and 2, that will always happen. So what do you notice when you do this? You get the same thing. What that's telling you is these formulas only apply if, when you take the middle term and divide it by 2 and square that, you end up getting the same thing that you would have gotten if you multiply the outer terms together. So the first question is, does that formula apply to x squared plus 20x plus 100? Well, to see if it applies, take your middle term, divide that by 2, that gives you 10x, and then square 10x, and that gives you 10 squared, which is 100, and that gives you x squared, which is x squared. Now compare that to what would happen if you multiply the two outer terms together. If you multiply them together, you get 100x squared. You get the same thing. So if that happens, and only if that happens, you can use the formula. Now notice these are both plus signs. Let's take a look at those formulas. The one that has both plus signs says it factors like this. It factors as whatever a is plus whatever b is squared. So a is whatever you get to square x, and the thing you would square to get x squared would be just x. B is whatever you would square to get 10, and that 100, and that's 10. So the way it factors is like this, which another way to write that would be x plus 10 times x plus 10. Either way is fine if you're factoring. So how does this work? You look at this thing and you see if dividing that by 2 and then squaring it gives you the same as the product of these two. If it does, you can use the formula. And what does the formula say? The formula basically says, what would you square to get x squared? X. What would you square to get 100? 10. You put those in there, and that is how it factors. Or you could write it that way. Okay, let's try it with this one now. First, you have to see, does the formula even work? To see if the formula works, you do what I said. You take the middle term, and you divide the middle term by 2. So we're going to take the negative 16x. We'll divide that by 2. We get negative 8x. Then you square that. If you square negative 8x, negative 8 squared is positive 64, and x squared is x squared. And then you ask yourself, if I multiply that guy by that guy, would I get 64x squared? You do. Since all of that works, you can use the formula. So the answer is going to look something like that. Now this time there's a minus here, So that tells us we're going to use the formula that has the minus there. And the formula basically says this. You ask yourself, what would you square to get 64x squared? You'd square 8x. What would you square to get 1? You would square 1. Because there's a minus there, you put a minus. That is how it factors. That is the answer. Or if you prefer, you can write it as 8x minus 1 times 8x minus 1. Now we're going to do this one. First, we have to ask ourselves, does the formula apply here? Well, to see if the formula applies, you take the middle term and you divide it by 2. So as soon as I get some erasing done here, I'll divide the middle term by 2. 7x over 2, you can't really simplify that, so that's 7x over 2. Then you ask yourself, if I square that, will I get this other thing? Well, that gives me 49x squared over 4. Does that give me the same thing that I get by multiplying these two? No, because of the over 4 part. So that means Formula 1 and Formula 2 cannot be used on that. So how do you factor that? That's not the point. The point is you cannot use Formula 1 or Formula 2. Okay, so that's how 1 and 2 work. Then there's 3, 4, and 5. Now, 4 and 5 have cubes in them. You see the cubes. The first one's called the difference of cubes because it's got subtraction, which means you have a difference. The second one's called the sum of cubes. Both of these formulas are identical except for the signs. These are sometimes called SOAP formulas. SOAP is just a way to help you remember the formula. The S in SOAP means same. The O in SOAP means opposite. There's a couple ways to look at what the AP stands for, but I'm going to say that it stands for always plus. So look at the formula. It started with a minus. The first thing in the formula is a minus. It's the same. The second thing in the formula is the opposite of that, which is a plus in this case. And the third one is a plus, like it says, always plus. Look at the second formula. It starts with a plus. The first one on the other side is the same. The second one is the opposite. And the third is a plus. That's what SOAP is telling you. So you need to have these formulas memorized. And this is a different formula. This is what's called the difference of squares formula, which looks as you can see. Okay, we're going to see how you can use these formulas to do some factoring. So we're going to start with the example over here to the left as soon as I get all this erasing done. So we're going to factor this thing. So what do you have? You have two terms. The only way we've learned so far to factor something with two terms is these three formulas that start with two terms. So you got to figure out which formula applies. Well, notice both of these numbers are multiples of 3. So that means it's not this formula. It's not the one where you need multiples of 2. Notice that we have a minus in the middle here, and this is the one that has the minus with the 3's in it. So that's the formula we use. The next thing you do is you make this look like the left side. In other words, the left side is a third power minus a third power. So you ask yourself, can I write this as a third power minus a third power? You can if you put here z to the 10th. If you put here t to the 7th, that's what this is equal to. Because when you have something that looks like this, you multiply powers and that gives you 30. You multiply powers and that gives you 21. So that's the first step. Make it look like a cube minus a cube. Then what the formula is saying is this. It's saying this is equal to this thing, where A is this and B is this. The thing circled in blue is A, and the thing circled in blue here is B. So everywhere you just put those things in place of the A and the B. So the parentheses is supposed to have the A minus the B, so we take A, which is Z to the 10th, and we do minus B, which is T to the 7th. In the second set of parentheses, you're supposed to square the A. So we take our Z to the 10th, and we square it. Then, after that, you put plus, and you multiply the A and the B together. So plus Z to the 10th times T to the 7th. And then, after that, you square whatever B is. So you put a plus, you take your B, which is T to the 7th, and you square it. So that's the answer, except it's not simplified. So let's simplify. This gives us Z to the 10th minus T to the 7th times, this is Z to the 20th. This you can't simplify, so it's basically Z to the 10th, T to the 7th, and this is T to the 14th. And there's your answer. This factors like this. Now you know that when you factor something, you can check and see if it's factored correctly by multiplying it all back together and see that you get the original back. Well, I promise you, although I'm not going to show you, but I promise you, if you actually multiply all this together, a lot of different terms will cancel, and you will literally end up with this back. So it does work. Okay, let's move to the next one. We're going to factor this. So, how do you factor this? Well, think about what you would do if you're taking a test. On the test, if it said to factor this, you ask yourself, well, I have two terms. Do I have any formula that works with two terms and a minus? Yes, we do. Let me scroll back. Both of these formulas work when you have two terms with a minus. Now, this formula works if the powers are multiples of 2, and this formula works if the powers are multiples of 3. Let's see what we've got. Well, we don't seem to really have either one, but we know that 9 is a power of 2, so if we could write this part as a power of 2, that would also help. Well, if you think about that, this is 2x to the third squared, because 2 squared is 4, and x to the third squared is 6. So our original thing looks like something squared minus something squared. That's called a difference of 2 squares. And that's one of your formulas, which instead of scrolling back, I'll just write it for you, is that. So we can apply the formula. This is what A is. This is what B is. So let's apply the formula. The formula says the answer is whatever A is minus whatever B is times whatever A is plus whatever B is. And that is your answer. This is how that factors. And again, not that I'm going to do it, but if you wanted to check it, you could FOIL these two guys together. You would see that some things are going to cancel, and you would end up with exactly this. So this is how it factors. Let's move down to the next one. We're going to factor this one. Again, it's got two terms. Again, it has a minus. And the only formulas we have for two terms and a minus are a square minus a square and a cube minus a cube. Well, we know 64, sorry, not 64, we know 16 is the square of something. Could we somehow, keep writing the wrong thing, could we somehow write that as the square of something? Yes, we could. That's k squared. squared. So we have rewritten the original as something squared minus something squared. We have that, so we can use that formula. Again, that formula says the answer is a minus b times a plus b, which, by the way, the order doesn't matter. You could say a plus b times a minus b. It's saying the same thing. Either way is fine. So this is equal to the two things added times the two things subtracted. The two things, this is a and this is b, the two things are k squared and 4. And you might think we're done, but we're not. It is factored, but factor means, unless you're told otherwise, factor completely, and there's more you can do. We don't know any way to factor this portion any more than it is, so that's not going to end up changing. But we can factor this. We can factor that because that's a square minus a square. So let me leave a little room here. We're going to look at how you would factor k squared minus 4. Well, that is the square of k minus the square of 2. So again, it's a square minus a square, which factors as so. So this factors as k plus 2 times k minus 2. That means we can replace this, the thing we just factored, with the answer we got. We can replace that with k plus 2 times k minus 2, and we still had that part, k squared plus 4, and there's your answer. That's how the original problem completely factors. Let me scroll back a little bit. This was the original problem, and this is the answer to how it completely factors. Okay, let's move on. We're going to factor this one. Again, we have two terms. This time we have two terms with a plus sign. We have three formulas for two terms. Let me scroll back and show you. We have three different formulas that start with two terms. The one for this, the one for this, and the one for this. And this formula has a plus in it. The other two don't begin with a plus. And notice the problem we have right now has a plus in it. Since it has a plus in it, we're going to use that formula. We're going to use the formula for a cube plus a cube, factoring as a plus b times a squared minus ab plus b squared. This is your SOAP formula. That one is the same as that. That one is the opposite of that. And that one will always be a plus sign. So there's the formula, which you do need to memorize. Okay, so how do we do it? Well, since our left side looks like a cube plus a cube, we have to write the original thing as a cube plus a cube. So we have to figure out, what would you raise to the third power to get 16p cubed? And what would you raise to the third power to get 2h cubed? Well, that's going to be a problem. So we're kind of stuck at the moment. But you need to remember the basic, always first thing you should think about rule of factoring. Anytime you are factoring anything, the first thing you should really do, and I should have done this on every problem on this section, but I didn't want to spend your time on this, but the first thing you should always do is ask yourself, is there a GCF you can take out? And if there is, do that first. Well, we can take a 2 out of that, giving us 8p p to the third plus h cubed. So our final answer to this problem is going to be 2 times whatever this factors as. So now we're going to factor that. The same discussion we had a moment holds. We're still trying to turn that part into a cube plus a cube. Well, now we can do it because this is 2p cubed. That would give us that. And this is h cubed. So now we can do it. What do? Just like before, we treat this as our A, this as our B, and we put those everywhere we see A and B. So that's going to be equal to the A plus the B, so the 2p plus the h, times the square of the A, so the square of A, the square of the quantity 2p, minus the product of those two things, so 2p times h, and then plus the square of the b, and that's the square of h. We just need to simplify that a little bit. That's going to give me 2p plus h times 4p squared minus 2ph plus h squared. And you might think that's our final answer. And it's close, but it's not. Remember, the question said to factor this. The first thing we did eventually was take the 2 out of it. And then we spent all of our time factoring that part. But don't forget there was still a 2 in front. So we need to slap a 2 right in the beginning of this thing. And that is our final answer. If you were to multiply all of this stuff together, including that 2 in front, you would get the original thing back. So that is how you do that one. Okay, we're going to factor this. Now, you could factor this using the AC method, but it would be a bit of an annoyance to do it because the numbers are so big, but you could. Instead, I'm going to go back to what we did in the very, very beginning. We said in the very beginning, if we have something that looks like that, we can use either Formula 1 or Formula 2 to factor it as long as it satisfied certain criteria. What does it have to satisfy? Well, remember, what you do is you take your middle term, negative 84xy, you divide that by 2, which will give you negative 42xy. Then you square that. And if you square that, let me grab a calculator here, because I don't know what 42 squared is. If you square that, you get 1764x squared y squared. And then the question is, okay, if I multiply these, do I get the same thing? Well, that will give me whatever 36 times 49 times x squared y squared is. Well, I've certainly got the x squared y squared part, and 36 times 49 is 1764. So that works. What does that tell us? Well, since that works and since there's a minus here, that tells us we can use formula number 2. Let me go back and remind you what number 2 says. Since that works, and since there's a minus, we can use number 2. And number 2 says the answer is just whatever A is minus whatever B is, and then put a square on that. So that is going to be the answer. So now we got to figure out what A and B are. Let me just copy this thing down. We've got 36x squared minus 84xy plus 49y squared. The left side of our formula looks like a squared minus b squared. So that tells us we need to, excuse me, that's not what it looks like. it looks like a squared minus 2ab plus b squared. So that tells us we need to write that so it looks like the square of something, and that does look like the square of 6x. We need to write that so it looks like the square of something, and that does look like the square of something. It looks like 7y squared. And I don't really care about the middle at this point because we've dealt with the middle. So a is 6x and b is 7y. And remember that factors as a minus b quantity squared. So in this case, it factors as 6x minus 7y squared. And that is the answer. That is how it factors. Or if you prefer, you can write that as 6x minus 7y times 6x minus 7y. So you can write your final answer like this. You can also write it like that. Let me see what else we have coming up. This is the last one. Okay. Take a moment and just read this so you see what it's saying. So I'm hoping you've read it. Basically, this is saying that rule number 1 applies to this one. Since rule number 1 applies to this one, we know something about what the middle has to be. Because remember, the middle part, if you square it, or if you divide it by 2 and then square it, would have to give you the same answer as 16x times 25. So let's look at what 16x squared times 25 is. If we multiply 16 times 25, that's going to give us 400. So that's going to give us 400x squared. So what would the middle term have to be if, after you divide it by 2 and you square it, you get that? Well, the thing you would square to get that would be 20x squared. Because 20 squared is 400. I'm sorry, 20x. Because 20 squared is 400, and x squared gives you x squared. But remember, to get to that point, we're supposed to divide by 2. And what would we have started with if we divided by 2 to get that? 40x. I know that's confusing, and don't worry, you don't really need to know that. But think of it this way now. If that was 40x, you would first divide that by 2 to get 20x. You would then square that, which would give you 400x squared. And since that's the same as 16x squared plus 25, that tells you, yes, it does factor that way. So the answer to what belongs in the blank, again, you really don't need to know this. This is extra, but the answer to what belongs in the blank is 40x. I believe that's the end of this recording. Yes, it is.